Hi everyone. Welcome to our adventure in videotaping experiments for you to watch and collect data. This recording is for Experiment 5, aluminum analysis. The experiment is one that works with gas behavior and gas laws. We will discuss the topic of gases in the lab session. The purpose of this video is to show you how the apparatus was set up and how it was used to collect data. I will be working through the procedural steps in your lab manual. You might find it helpful to follow along in your lab manual as you watch this video.
Yep.
Okay, we've already set up the apparatus, and in just a moment we'll use the camera to show you the entire apparatus. But if you're following along in your lab manual, Part A says to get the temperature of the water in the apparatus, so that's what I'm going to do at this point. I've got the thermometer probe in the water that's in the funnel, and you can see what the temperature is.
Okay.
Okay, also you see in the lab manual it says we need to get the vapor pressure of the water, and so we're looking at the appropriate page in the Handbook of Chemistry and Physics. You see at the top of the page there the titles of the columns, temperature, and then 0.0 and 0.2 and so forth. So this can read to the first decimal place on the temperature. Now Dr. Dene is going to go down to the appropriate section where we were with the temperature that you just saw in the video. And so now what you should do is make the appropriate reading off of those columns with the temperature that you saw in the video. And also you see in the lab manual it says that we need to know the atmospheric pressure today. So we have measured that, and the atmospheric pressure today is 0.9400 atmospheres. Okay, I have already cut a few pieces of the pop can, soda can, and so I'm going to first put the weigh boat in the balance and zero it out. And now I have a very small piece of the pop can that okay, that's not enough. We need about 0.025. I've got several pieces here, and it looks like it's a little bit too much, so I'm going to carefully take one out. The reason why I don't want it to be more than 0.025 is because if I generate too much gas in the apparatus, I won't be able to measure it appropriately. So that is the mass then that we can use, and so I'm going to take this over to the apparatus. Okay, I'm going to now transfer the pieces of aluminum, the soda can, into a small test tube. And there we go. Did I drop one? There should be. Yes, there are 3 pieces in there.
You want to bring it up to the camera?
There are 3 small pieces of soda can in there. And now I'm going to put 15 milliliters of 6 molar hydrochloric acid. First measure it into a graduated cylinder. And then I'm going to put that into the large test tube that is mounted on this ring stand. And then finally, I'm going to take the small test tube that has the soda can in it, and actually for safety I'm going to take this off of here so that I can tilt this slightly and just slide it in on the side. And now the small test tube is inside of the large one, inside of the HCl, but there is no HCl inside of the small test tube at this point. So now I'm going to anchor that back onto the clamp. Okay, so now we can focus on the apparatus that has already been set up. You can see that we've got a stopper, a 1-hole stopper, connected with glass tubing to amber tubing, and that is then connected over to the top of a burette. I've already sealed off with parafilm the top of this connection because that is a typical place where gas can leak out. We have a burette, and at the bottom of the burette we've removed the burette tip, and we now have tubing that is connected directly to that, and that tubing then is connected to the bottom of a funnel. This whole apparatus was previously filled with water, and you saw that earlier, that we measured the temperature of that water. The purpose of this apparatus is to function as a type of manometer, and this funnel is going to function as a leveling bulb. When the water level in the bulb and in the funnel and in the burette are equal to each other, which I don't think they are at this point, but when they are equal to each other, then we know that the pressure outside of this apparatus is the same as the pressure inside of the apparatus. Now, I'm going to do a couple of adjustments. Your lab manual suggests that we start with the level of the water between 0 and 5 milliliters, and it is not yet at that point. So I'm going to loosen this connection over here to allow air to go into the apparatus, and then I'm going to change this level, drop the burette a little bit so that it now drops into that range between 0 and 5. Now I'm going to...
Sorry, folks. Didn't focus correct.
Now I'm going to tighten that up again. And at this point, we want to check the apparatus for leaks. So what I'm going to do is make sure that that's on there tight. Another place for leaks to occur is at this connection point. So I've taken a piece of parafilm. I'm going to just stretch that parafilm around there and make this a hopefully leak-tight connection. At this point, after this is done, we hope we don't have to take that apart again to find any more leaks in the apparatus. Now, to test this for leaks, what I'm going to do is to raise and lower the funnel and watch what happens here in the burette. There is going to be some movement of the water in the burette as I raise and lower the funnel. However, air inside of this apparatus is compressible, and that's why it is moving some. But as I drop this down, we see that the level in the burette is not moving freely as it would be if there were an air leak. And so I can be confident that we don't have an air leak in this apparatus at this point. Now for the little more challenging part, and that is to get the level in the burette to be level with the funnel. And so for that, I have to use my best judgment about how level these are, and it looks like I may be fairly close. I'm going to try to raise the funnel just a little bit. And this is about as well as I can observe it at this point, but it looks like the level in the burette is level with the funnel outside, which tells me again that the pressure inside of the apparatus is the same as the pressure outside, which I mentioned earlier what the pressure was. So now that we've leak tested it, we are ready to start the reaction. This is a reaction between the aluminum in the pieces of pop can and the hydrochloric acid, and that reaction will generate hydrogen gas, which will then bubble up and then flow through the tubing and flow through into the burette and push the level of water in the burette down. So we are ready to start the reaction, and I'm going to do that by just tilting the test tube and then tilting it backwards to try and get that hydrochloric acid into the small test tube. And I know it's a little bit of an optical illusion, but you see a meniscus here and a meniscus there. So I do have hydrochloric acid inside of the smaller test tube. Now it takes a little bit of time for the reaction to get going because the hydrochloric acid can only contact the aluminum along the cut edge there. And so in a little bit we will start to see perhaps some gas bubbles starting to form. And you might, there went one, you might be able to see now some gas bubbles starting to form along that cut edge. And in fact there's hydrogen being generated. That's why it all rose to the top, because the hydrogen gas is helping to buoy that aluminum up. So I'm just going to clamp it back in here again. There's no point in me holding it the whole time. And as that reaction gets going more and more, as I mentioned, the hydrogen gas, which you can now see more bubbles forming, that hydrogen gas will flow through the tubing to the burette, and as that pressure builds up inside, then it will start to push the water down. Okay, now you can see that the level in the burette is dropping rather quickly. And if Dr. Dene swings over to look at what's happening in the reaction flask a moment, we can see that it's bubbling quite vigorously. And now if we go back and look at the burette, we see that it is dropping rather quickly. So what's going to happen is that the hydrogen is going to continue to push the water out of the burette. If we look at what has happened in the funnel, of course the level in the funnel has risen as the water comes out of the burette and up into the leveling bulb, which is the funnel. When this reaction finishes, then we will need to re-level the leveling bulb with the meniscus in the burette. And so we're probably almost there at this point, in that the reaction has slowed down quite a bit, and and it looks like the level in the burette has quit changing. I'm going to just give a little bit of a tap to this to make sure that we've got all the hydrogen out of there. Okay. Now, at this point, we need to again determine that the pressure inside of the apparatus is the same as that outside. At this point, because the level in the burette is lower than the level in the funnel, that means the pressure inside the apparatus is higher than the pressure outside. But because we don't have a pressure sensor inside the apparatus, we don't know what that pressure is. And so the only way we will be able to know what the pressure is, we have to, again, make the two levels equal with each other. And so I can do that in a couple of ways. I can, looks like this apparatus is such that what I'll be able to do is just simply raise the burette, and then again make sure that the levels are the same at this point. Again, as well as I can determine it. And so Dr. Dene will now focus in on that and show you that the levels are, as well as we can determine, equal to each other. Now, what I had forgotten to do in the earlier part of this video was to zoom in on the burette and to actually read the burette reading at that point. I would need to read the initial burette reading and the final burette reading. What I plan to do is run this experiment several more times and generate several sets of data for you to use. So we won't necessarily need to use the data off of this particular run.